Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 12.5, adding and subtracting rational expressions. Again, a rational expression is just a fancy term for a fraction. So what we need to do first is we're going to review Chapter 12. So what I would like you to do is go ahead and take a shot at examples 1 and 2 here. Pause the video, see how you can do. When you come back, I will have the answers for you. So go ahead and give this a shot and see how you do. All right, and so example 1, what we had to do is factor the numerator. When I factor the numerator, I would get x minus 2 times x minus 2. That is fully factored. No more steps can I do with that to factor. 2 minus x is actually what I need to do is turn that around. My x is behind my 2, which I don't like, so I put it out front. It gave me negative x plus 2. At that point, what I need to do is factor to make my x positive. So in the next spot down here, I took out a negative 1 to make my x positive and my 2 negative. I can go ahead and cancel the x minus 2's. So I'm left with x minus 2 over negative 1, which if I actually were to divide that, it would be negative 1 times x minus 2 is the same thing. All right. On to example 2. The first thing I did is I factored the x squared minus 1 into x plus 1, x minus 1. The 7x stays 7x. 2x plus 2 factors into 2 times x plus 1. And the 2x will stay the 2x. I'm not sure if you can see the right side of my first line of work there, but I think you'll be able to figure out what's going on here in a second. At that point, I have everything fully factored, so I need to keep, change, flip. So I'm going to keep my first fraction exactly the same, x plus 1 times x minus 1 over 7x. I'm going to change my division to multiplication, and I'm going to flip my second fraction. So the 2x was actually in the denominator in my first step of work, and the 2 times x plus 1 was in the numerator. Since I have to multiply by the reciprocal, I did flip those. Now, what can cancel is the x plus 1's and the 2's. What you're going to notice here is I've actually missed a step that I could do. I end up with x times x minus 1 over 7x, where I can actually cancel the x's out. So I end up total with x minus 1 over 7. All right. Now, let's talk about our new lesson. Our new lesson is adding and subtracting fractions. The first thing that we need to remember about adding or subtracting fractions is that our denominator must be the same. When our denominator is the same and we're adding or subtracting fractions, then all we have to do is add or subtract the numerators. Okay? So let's look at example A. The first thing I'm going to look at is, are my denominators the same? So I have x plus 3 and x plus 3, meaning my denominators are the same. So I'm going to add the 2 plus the 5 to make 7 over my like denominator, which is just x plus 3. And I'm actually done there. Okay? On to B, are my denominators the same? Where x minus 5 and x minus 5 are the same, meaning I can add x plus 3x, which is just 4x, over x minus 5. Once I have them added, I am going to look and see if I could factor or cancel anything. In the first two cases of here, that is not possible, so I am then just done. On to C, again, I need to check and see if the denominators are the same. So I have x plus 1 and x plus 1. They are the same. So I can take 5x minus 2x, which is 3x, over x plus 1. Again, I want to check and see if there's anything I can simplify, anything that I can adjust here, and there's not. So I'm done. Now on to D. D is a little bit different animal here. I am going to check and see if my denominators are the same. 3x plus 6 and 3x plus 6 are the same. When I have a binomial that comes after the subtraction sign, so what I'm talking about here is the fact that in between is subtraction and I have an x plus 7 behind the subtraction sign. What I want to do is I want to change my subtraction to addition and change all the signs that come after it. All right. So I changed my middle sign to addition, and I changed all the signs after it. What that does is that forces me to understand that that 7 is supposed to be negative. A common mistake is people will make the x negative, but they won't make that 7 negative. So now my denominators are the same, 3x plus 6. So I'm going to take 7x plus the negative x, so it's really 7x minus x, which is 6x. And I'm going to take negative 2 plus negative 7, so really that's negative 2 minus 7, or negative 9, over 3x plus 6. At this point, like I've been saying in the last couple of examples, I do want to look and see if I can factor this any further. Well, 6x minus 9, 6x and 9 are both divisible by 3, so I can take out a GCF of 3, leaving me with 6x divided by 3 is 2x, negative 9 divided by 3 is negative 3. Over 3x plus 6, 3 and 6 are both divisible by 3 as well. So I can take out a GCF of 3, leaving me with 3x divided by 3 is x, 6 divided by 3 is 2. And I am to the point now where I can look and see, is there anything I can simplify, anything I can cross out. Well, I can get rid of these 3's out front, leaving me with 2x minus 3 over x plus 2. All right. On to example E. It's the same thing going on here where I have a subtraction in between. Therefore, what I want to do is change the subtraction to addition, change all the signs that come after it. So I've changed the subtraction to addition, and I've changed the 3x to negative and the negative 4 to positive. I'm going to check my denominators. 5x plus 2 and 5x plus 2 are the same. Therefore, I can just add my numerators now. So 2x plus negative 3x would be negative x. 1 plus positive 4 would be positive 5 over 5x plus 2. At this point, there is not much I can do to simplify this. I won't be able to cancel anything out. What I could do is make my x positive by getting a negative 1 out front and making this x minus 5 over 5x plus 2. That is a pretty good practice on the fact that that does come up. And when that comes up, we tend to have to take out the GCF of negative 1 in order to be able to cancel things. So you may want to do that. I wouldn't count anything off on it though. But that is my final answer, negative 1 times x minus 5 over 5x plus 2. Now on to F. F is a little bit different. F has denominators that are not the same. So what we're going to do is we need to find the LCD, or the least common denominator. How I'm going to do that is I'm going to break up my current denominators. I have 3 times x, and I just have an x. I'm going to circle anything that's shared. So I have x and x. Anything I circle, I write down 1 time. Now, anything that's left over, I need to underline. So this 3 is left over. I'm going to write anything that I underline down as many times as it shows up. So this 3, I'm going to write down 1 time. So my LCD is x times 3, or 3x. Okay? So what I need to figure out is, how do I make my denominator into my LCD of 3x? So what do I have to multiply my first fraction by? It's already 3x, so I don't have to multiply that by anything. However, my second denominator is just an x. So what do I have to multiply x by to turn it into 3x? I'd have to multiply it by 3. Anything I multiply my denominator by, I must also multiply my numerator by. So this leads me to have 2 over 3x plus 3 over 3x. Well, 2 over 3x plus 3 over 3x. Now both of my denominators are 3x, meaning I can add the 2 and the 3 to make this 5 over 3x, and I will be done at that point. Well, that is the end of our lesson for today. The most important pieces to remember at this point are we have to have a common denominator in order to add or subtract our numerators. When you do have a common denominator and you add or subtract, it will not change. Once I have a common denominator, I'm just going to bring it over. Once we have the two fractions added or subtracted with each other, we're going to look to factor and simplify, just like we did in our last unit. If you have any questions over this lesson, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.